Statistical graphs are the diagrams that are used to visualize statistical data. And there are two types of statistical data that are needed to be visualized: quantitative data and qualitative data. That's why you have separate diagrams that are used to visualize quantitative data and qualitative data. For quantitative data, the statistical graphs used are: number one, histogram. So these are all for quantitative data. Number two, frequency polygon. Frequency polygon. Number three, frequency curve. Frequency curve. Number four, line chart. Number five, Ogive. And number six, scatter diagram. Scatter diagram. As for qualitative data, you'd use the following statistical graphs: bar chart, pie chart, map, and pictogram. Okay. First, let's look at the diagrams or the statistical graphs used to represent quantitative data. So here are three of them which are really important: histogram, frequency polygon, and frequency curve. The reason I have kept three of them together is because they are related to one another. Let me show you how. First, you have histogram. Histogram is used to represent quantitative data with the help of x and y axis. So on x-axis, you keep the quantitative data, but the type of quantitative data used to visualize is your continuous type. So you'd use continuous quantitative data on x-axis. On y-axis, you'd keep frequency. Let me give you an example. Okay. So let's say weight. You put weight on x-axis and number of women is the frequency on y-axis. So your weight can be 50 kg, 60 kg, 70 kg, 80 kg, 90 kg, and 100 kg. Number of women: 0, 10, 20, 30, 40, 50. Okay. Upon statistical study, it is found that 10 women have weight in between 50 and 60 kg. 30 women have weight in between 60 and 70 kg. 40 women have weight in between 70 and 80 kg. 20 women have weight in between 80 and 90 kg. And again, only 10 women have weight in between 90 and 100 kg. If you see carefully, you'll see that there is continuity in your data. The bars that have been drawn, they are connected to one another. Even if an interval is present in between the graphs, in between the bars, there will still be continuity. See, the reason weight is a continuous data is because number one, it has many possible values: 50 kg, 60 kg, 70 kg, 80 kg, and so on. And number two is because they have in between values, like in between 50 and 60 kg, there's your 51, 52, 53, and so on. And again, in between 51 and 52 kg, you have 51.5, 51.52, 51.523, and so on. So there are a lot of in between values. Basically, the values are present continuously. That's why the frequency also was shown with the help of bars that are connected with one another. And this right here, a graph used to represent continuous quantitative data using x and y axis, is what we call a histogram. Now let me show you how you can draw frequency polygon as well as frequency curve using histogram. First, let me make the graph smaller. Okay, so here's your histogram. Copy, paste. Now this is what you need to do in order to make a frequency polygon from a histogram. From each of these bars that are present, take a midpoint. So a midpoint here, a midpoint here, a midpoint here, a midpoint here, and a midpoint here. Connect each of these midpoints with the help of straight line. One straight line, another straight line, another straight line, another straight line. Draw perpendicular lines from the first midpoint as well as the last midpoint in order to close the given diagram. This polygon that you get right here, a closed polygon that you get, is what you call a frequency polygon. Okay, next you have frequency curve. In frequency curve, okay, let me arrange. All right, in frequency curve, what you do is basically replace these edges, sharp edges, with the help of curves. So replace these sharp edges with the help of curves. Let me show you how. So first you take the midpoints, midpoint here, 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 here. Instead of joining them with the help of straight lines, draw curves along them. So one here, here, like this. Okay, so these are the curve. So this curve that you get is the frequency curve, and this is how you can draw frequency polygon and frequency curve from a histogram. All three of them are used to represent continuous quantitative. In line chart, also you have two axes, an x-axis and a y-axis. On x-axis, you have time. Let's say I have taken time in years. So there's 2001, 2002, 2003, 2004, 2005. And on y-axis, you have events. You have various events. Let's say the event that I take is number of people with cancer. Number of people with cancer in thousands. So you have 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. In 2001, the number of people with cancer in thousand is 10,000. In 2002, it increases to 30,000. In 2003, it's still 30,000. In 2004, it increases to 60,000. And in 2005, it falls down to 20,000. So if you connect these dots or plot a line joining these dots, you get something like this. So you get a graph that is composed of lines. And this right here is what you call a line chart. So line chart is used to represent events over time, and events over time is what we call a trend. So line chart is a statistical diagram which is used to represent trend of quantitative data. Okay. Next up, we have Ogive. Ogive is similar to line chart. That is, it also has time on x-axis. However, on y-axis, instead of having your typical frequency, you have something called cumulative frequency. And what's cumulative frequency? For that, you have to wait for the next lecture. So the graph in between cumulative frequency and time is what you call and ogive. Okay. Finally, there's your scatter diagram. In scatter diagram as well, there are your two axes. There's your x-axis and y-axis. In scatter diagram, on both x-axis and y-axis, you have quantitative data. Two different quantitative data. Let's say on x-axis you have your height and on y-axis you have your weight. This diagram is used to find the correlation between the two different quantitative data. Our expectation is that as the height increases, the weight should increase as well, right? For that, we take individual people, we measure their height and measure their respective weight and plot the dot on the graph. So let's say we find a person of height 6 feet and the weight comes out to be 80 kg. Another person of height 5 feet and weight comes out to be 40 kg. Another person of height 5 feet but weight comes out to be 90 kg. Maybe the person is fatter. And you keep on plotting the dots for various heights and their corresponding weight. Heights and their corresponding weight. Heights and their corresponding weight. And then you draw a single line that is used to represent all the scattered dots. Let's say the line that you draw comes out to be something like this. Okay, so this is the line. This line is used to represent the correlation between two different quantitative data, and they are your height and weight. And the correlation comes out to be that as the height increases, the weight increases as well. And this is your scatter diagram. The reason it's called scatter diagram because the points plotted on the graph are scattered all over. And a single line or a single graph is then used to represent these scattered plotted dots. There are 4 different statistical graphs that are usually used to represent qualitative data or visualize qualitative data. There's your bar chart, pie chart, map, and finally a pictogram. In bar chart, as the name suggests, bars are used that is present within your x and y axis. So in y axis, you are going to represent frequency. And on x-axis, you are going to represent the variable or the data. In case of histogram, the type of variable used was a quantitative variable. And the type of quantitative variable used was your continuous quantitative variable. Let me show here. So a continuous quantitative variable was put on the x-axis, and on y-axis, there was your frequency. However, in case of a bar chart, there's your frequency on y-axis. However, on x-axis, you are going to put qualitative data instead of quantitative. And the type of qualitative data is going to be discrete type. So discrete qualitative data. Let's get an example. Let's take an example. So on x-axis, qualitative data is going to be presence and absence of diabetes. So diabetes is a qualitative data. Why? Number one, you cannot measure it. You cannot measure how much diabetes is present in a person. You can measure sugar level, but not diabetes. And number two, you cannot compare diabetes of two persons. You can't say that person A has more diabetes than person B. However, you can compare sugar level. Okay, so there's your diabetic people. And then there's your non-diabetic people. These are your qualitative data on x-axis. Discrete qualitative data on x-axis. On y-axis, you have your frequency. 10, 20, 30, 40, 50, 60. Upon statistical examination of a particular place or a particular hospital or a particular city, it was found that 40, let's not say 40, 30 people, they are diabetic, while 60 people, they are non-diabetic. So here, two different bars, one bar here and another bar here, which are not continuous. There is no continuity in between the bars. In case of histogram, there's continuity in between the bars because the type of data used was a continuous quantitative data on x-axis. However, here on x-axis, you have discrete qualitative data. So that's why there's a gap in between the two bars. So this right here is a bar chart where bars have been used to visualize discrete qualitative data. Next up, you have pie chart. In pie chart, instead of using a bar, you would use a pie or a circle. Here also, the type of data used is going to be a discrete qualitative data. So let me give you an example. Let's say the part that I have represented in red represents diabetic people, and the part that I have not represented in red represents non-diabetic people. So this means that here you have 30 people who are diabetic and here you have 60 people who are non-diabetic out of total of 90 people. So that's your pie chart. Again, the type of data represented is discrete qualitative data. Then third, you have your map. Map, it's simply a map, nothing else to say. So there's your map with some peculiar destinations. Okay, that's your map. Finally, there's pictogram. Pictogram is a layman way of representing qualitative data, where basically you are going to show pictures so that even kids can understand what's going on. So this is your frequency. This is your frequency. And then here's your qualitative data. The qualitative data is the fruit that the child likes, and the frequency is the number of children who like the fruit. So the fruit that children like is pear, and the number of children who like pear is 1, 2, 3, 4, 5, 6, 7. The fruit liked is watermelon, number 1. Orange by one child, apple by one child, banana by one child. Or one fruit could be representing 10 children. In that case, the number of children who like pear is going to be 10, 20, 30, 40, 50, 60, 70. 70 children like pear, 10 children like watermelon, 10 children like orange, 10 children like apple, and 10 children like banana.